Next in this session, we'll see the bit fields in the structure. Okay. So what are these bit fields and what is the real use case? Okay. So what we know is integer takes 4 bytes and character takes 1 bytes. So now what if we want to use an element of a structure only to store 6 bytes, 6 bits? Okay. 6 bits, that is not even one full byte, or say 12 bits, which is 1.5 byte. So to do such things, we can use the bit fields operations. Okay. So what it does is it will give us it will allow the programmer to use the memory efficiently by defining only certain bits, or not certain, only the required bits, and the other bits are not used and those are not padded as well. Okay. So this we'll see in the example how it will increase the memory efficiency. Okay. And moreover, in the embedded world, when you deal with boards, so you might see a different registers. Correct? So what are these registers in embedded controller? Well, I'll just briefly touch on that. That registers are something which are defined by the board, where those control the board behavior. Okay, meaning, and the register addresses are fixed. Correct? And each register, I mean, I'll just take an example later in the C code demonstration. Each register, say that is a 32-bit field, is again subdivided into different fields. Okay, so say a status register of 2 bytes, counter of 6 bytes, and then so on and so forth. So to access these 2 bit 6 bits separately, we can make use of these bit fields. And also, if you have seen any communication protocol, okay, say for TCP/IP or anything, which has a header, or even say Ethernet protocol. So every protocol has a header, but that header has different fields, and each field has a varying length of bits. Correct? So a header ID would be of 2 bytes, okay, to indicate IPv4 or IPv6. So to extract such things, we can make use of bit fields. Okay. Let me demonstrate the usage of the bit fields using a C program. Okay. So like, first we'll see how we define the bit fields. Okay. So I will take again a sample structure. Yeah. And now here, say I need integer A, or say let's take base register. Okay. Let's define it as base register. And first one is an integer, and it is the status register of 8 bits, sorry. Next, counter of 8 bits. And next will be the data of 8 bits. And next what we have is say error. Okay, if there is error of 8 bits. Yep. So now we have defined 3 integers, but we can have a different lengths as well. Let's take 5, 7, make it only 2. Okay, so this is also possible. Yep. So now how do we use it? Or first we'll see how it is efficiently using the memory. Okay, so we should see a memory reduction, right? So if we don't have these bit fields here, ideally we will get 4, 4, 4, 16 bytes. Okay, but now we just have to sound these bits and round it off to the next 32-bit alignment. So 8 plus 5, 13, 13, 7, 20, and 22 bits. Correct. So let me define one struct, base register, base register B1. So let me print the size of this. Okay. I will not write anything. I can directly take size of and B1. Compiled. What it's printing? 4. You see, this is only 4 bytes. Okay, so we have defined 4 integers of smaller bit size, It has summed up to only 4 bytes. So this is where a memory efficiency comes into picture. So let's say, so can we have more than 8? Of course, we can have 15. So does it exceed 32? 20 plus 50, 35. Okay, it exceeds. Now we might see 8 as the size. Okay. See, this is 8. Why 8? Because 15 plus 5, 20, 20 plus 15, 35. So 35, round it off to a next because structure is again aligned. Yeah. So this is how we use bit fields. And can we set it also? Yes, see, we can set it. But a better use case would be when we see unions. P1 dot st equal to, right, 4. Yeah. B1 dot data, just define a 5-bit variable which will say 8. You can print these things as well. So you can extract these bits, or you can use these bits directly, bit fields. So just try to print st. So it's printing 4. Yeah. So this is all about bit fields and the efficient usage of memory.